Welcome to everyone. Hopefully you found yourselves in the right place. We're going to have an awesome conversation today around computer vision. I'm super excited about this conversation because as an avid attender of webinars myself, I think we're going to be able to hit this from a couple different and very interesting perspectives where we want to have a deep conversation around the technicality around computer vision and how do these projects come together, what is coming around the corner, what are best practices today that more of the technical and practitioner mindset are going to be really interested in learning about, and especially apply it to real life scenarios. And that's kind of the other side of the coin here, is that there's certainly business aspects to making AI decisions and applying computer vision specifically to an organization. And we're going to have a lot of perspective from the business, and why we invited Vu to join us as well. So I think you're going to get both sides of it. Is, how do we think about this from a business standpoint? And then how do I think about this technology as a practitioner? So hopefully you'll find it useful no matter what your background is. So with that being said, we can start with some intros. I will be your host today, and I'm joined by these amazing panelists. But for those of you that don't know me, my name's Steve Meyer. I am a co-founder of an artificial intelligence services firm, KUNGFU.AI. We're doing a lot of consulting and building custom solutions in the machine learning space, including computer vision. And my background is more on the consulting side. I spent 10 years doing digital consulting prior to KUNGFU, working predominantly with large Fortune 500 IT companies like IBM and IBM Watson Group. So I very much represent the business lens in terms of how do we know what problems to solve with machine learning, and what are some of the things we need to be mindful of when trying to roll out this very powerful yet complex technology solution. So with that being said, I want to introduce to you all my panelists. And Priya, I'll let you go first.
Sure. So I'm Priya. I'm a principal machine learning engineer at KUNGFU.AI. So I have a lot of experience doing machine learning projects from sort of customer journeys, from inception to from when they're thinking about, I want to do some AI, to actually delivering projects across different verticals, from retail to healthcare to autonomous driving. And here today, we are going to talk about how it applies to waste management.
That's my cue. Thanks, Steve, and thanks, KUNGFU, for hosting us. My name is Vu Nguyen. I'm a director in our corporate development innovation group. I've been with the organization, coming on 10 years already. Time flies. And I wear two hats. One hat is we're responsible for kind of the investments in startup companies on behalf of waste. And then the other half is looking at emerging technologies and, frankly, ready technologies to kind of fold into our organization. And we could talk a little bit more about what that looks like specifically when it comes to computer vision.
Excellent. Well, thank you, Priya, and thanks, Vu, for taking some time to help educate us all today. We're super excited about it. So, Vu, I'm going to point my first question to you because I'm very interested in this and have had some exposure to this, but I'm certainly curious to get inside the mind of you and waste management, and really help us understand the posture of an entity like waste management when they think of artificial intelligence writ large. How is waste management thinking about it today? How are they trying to embrace it?
Yeah, I'm going to take that in kind of a two-part answer. I think the first part is more of the lower hanging fruit, and then I'll talk a little bit more about the future of, I think, where we're going to be trying to position ourselves and getting to. So when I think about the lower hanging fruit, I'm thinking about just process improvements in general, right? As we, and most folks here know, Steve and Priya, for your benefit, we're now WM, no longer waste management, we're WM. And part of all of that is a branding and positioning of how do we become this environmental sustainability company, and no longer just dealing with trash. We are a materials handling company. And with that, comes our greatest asset, our logistics and collection assets, right? And this is no secret. I'll tell y'all, the way that we do maintenance today is a little bit reactive, right? We have a preventive maintenance schedule, et cetera, associated with our trucks, but that's similar to cars and passenger vehicles. You change your mile every 5,000, or change your oil every 5,000 miles. That's what you need to do. You change your air filter, certain duration, et cetera. But when it comes to those critical parts, we we let them break and then we fix it. So there's downtime associated with it, right? So we're starting to use AI in the function of predictive maintenance. And when we talk about predictive maintenance, we're using historical information that we've gotten off of these, the transmission, the engine, blah, 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 that we can start to hone in on when is the right time to fix all of this and prevent zero downtime, but also extending, the asset life as long as possible, meaning that you don't want to fix it too early and kind of, use capital expenditure to do so and money. You want to just time it perfectly, hopefully, so that you can optimize cost and then optimize availability. So that's kind of the lower hanging for using some of that predictive AI. And I think that's really introduced and taken a lot of momentum in the last couple of years. A lot of companies we see start to analyze some of these patterns and trends. So now taking the next step forward, so more, not necessarily futuristic, because I think the technology is here today and we're ready to implement it, but even, maybe one or two steps even more advanced than that is using computer vision to help augment some of our current businesses, right? And really taking what I'll call human interaction and automating it, right? So I'll give you guys some examples. Our trash truck drivers will drive and service the community. In this case, a lot of the commercial establishments, your Walmarts, Targets of the world. And if we notice a bin that's extremely overfilled and it's just a whole bunch of clutter everywhere, the driver would press a button on their computer and say, hey, it's overfilled. We should charge folks, because they actually have to get out and clean up and do all of those things. So there's extra processes in place for the driver. Well, now we have a camera that it's forward facing and it can identify all of that. And not only is it proof, right? Because a lot of times, as everyone here can imagine, the customer said, yeah, it was never overfilled. It's impossible, right? We do the right thing always. And you shouldn't be penalizing us for it. But now we have proof, right? We have proof that, hey, it is overfilled. And now we take that element, and although a little bit elementary, that element out of the driver's hand for them to be a driver and not necessarily be distracted with anything else, right? We really want the drivers to focus on driving, servicing our customers, and not worry about some of these ancillary things that, frankly, I believe technology can help augment and help them with. And that's one particular case. Even taking it a little bit further, Steve, we're starting to figure out how to classify and really get an understanding of the waste constituents, specifically in recyclables, not necessarily trash, right? So as your recycling truck goes down the road and picks up your recyclables, we'll try to get a good understanding is, are you doing a good job recycling, right? One of the rationales to all of this is, let's just say, and I'm at fault for this, I'll raise my hand to be the one to blame here. When I have a party of some sort, my trash can's full, I might dump it in the recycling can, right? And it's just organics and wet stuff and blah, blah, blah. Well, it might not be too big of a deal on a surface level, but let me help peel back the layers and give a understanding to the folks is, as that truck drives down the road, it picks up other people's cans of recyclables, et cetera. But now your load just contaminated other people's recyclables. So in that truck that goes down the road, all of it now is contaminated to some degree because you were just not great at recycling. So what we're trying to do is inform folks to say, hey, you didn't do the best job of recycling, please try again. Here's an educational tool, maybe a link or something like that associated with it. We can identify that real time as it's being dropped into the trash truck via camera being mounted on top. So those are kind of what I'll call, and Priya, I'm sure you can educate us on the actual terminology, but object classifications, right? You see that as it goes through, and you can identify that, and you have real proof. I think that's really the takeaway is you have proof that these events and things of that nature are happening, and then you're also automating it so that whatever the person's doing doesn't need to be focused on that.
So Vu, this is really interesting, and I want to parse one thing apart and separate the specifics of the computer vision use cases, because I want to dive into there in just a moment. But staying at a fairly high level for just a second, when you talk about strategically waste management is using artificial intelligence to automate processes or to make processes less manual or more safe. there's a lot of implications to that. How does waste management think about applying automation from a strategic standpoint?
I think when you think about automation, people automatically think about, replacement and taking away people and whatnot. I don't think that's necessarily the case from a strategic level. When we WM looks at, we think about this as augmenting people's jobs, right? We already have such a difficult time, and once again, probably very similar to other industries, attracting talent, right? And the folks that we have, we need to make sure that they focus on the priorities of what they need to be doing, and not necessarily giving them more and more things to do. And I think, you can really lose a lot of talent and workforce if you continue to pile on things. So that's where I think AI comes in and really helps take some of those, and frankly, in some degree, a lot of our roadmap, Steve, is we really want to automate as much as possible, in the sense that we want to make people's jobs easier. We want to upskill the folks that are coming in, so that they work on very interesting things, right? And then we also want to keep talent and make people want to stay here for the long term. It is becoming increasingly difficult. I think there's this great resignation that's happening, but that's been happening for a long time in the blue collar world, right? That's, nobody wants to be a driver anymore. Nobody wants to be a mechanic. And how do we start to make those things easier? Because what's happening at least in our industry, is we're piling on much more complexity than they really need. And how do we take it out of those folks' hands and make their job just so much easier?
Yeah, thank you for sharing that perspective. Priya, I'm very interested on your perspective, just generally speaking across computer vision, as someone who practices it every day, and I'm assuming you are also a student of the game and looking around what's next. From your perspective, what is the state of computer vision and what's coming around the corner? And I know you put together a couple of slides. I can call those up. Just let me know.
Yeah, we can talk through that, right? Talk through the slides. So yeah, we are on a hamster wheel of sorts, right? In terms of publications, research. But the thing is, the real hamster wheel is really in adoption. So it's no longer just, papers, right? But it's real implementations, right? We are at a point where we can actually take the state of the art and really try and really implement. There are projects where we are using some of the latest and greatest, solutions that are out there. So just to walk back and look at the history of the lay of the land, we started with CNNs. And, when ResNet came along, right, and beat humans at performance, we thought, image classification, object detection, we thought, yeah, that's great, right? And 2020, we have transformers taking over the world, right? And so once you're there with, transformers, so much advancements within like months, right? Vision transformers came out, and then within 3 months, we have Swin transformers out. So, between the different companies, this is such an open source culture, right? So Google comes out with one, and then, Facebook Meta comes out with, another competitive DIT, which is, at a lower number of images, almost 1/3 less, which makes it more palatable for, industry adopters like us, right, who take it and work with people like WM, right? So here in this slide, we are basically trying to sort of walk through why transformers work. So it's something that worked in natural language processing for the longest time. And now we are taking that and going cross-domain and applying it in computer vision problems. So like Vu was saying, right, object detection, object classification, semantic segmentation, right? For all of those problems, we've been able to use. So if you go to slide 6, right? So this is from 2020. This is January 10th, 2022 that we are talking about, where we have, there's a merging of convolutional networks and transformers happening here. Both technologies are starting to converge, which is great for us practitioners. So I guess the message here is that it is actually possible to take these papers and actually implement. We have done for not just for WM, for other projects. There are people on the call who can, talk about some of the applications. I don't know, Zizi, do you want to talk about Connext and how, that's being applied? I think one of you might have to unmute Zizi.
Way to put them on the spot, Priya.
Why not, right? We have stars, so let's use the stars, right?
Exactly. Yeah.
Hello. Can you hear me?
Yes.
Yeah, we can.
Yes, we
Oh, great.
can.
Okay.
Thanks, Zizi.
Yeah, thank you. I just saw the unmute button appear in my screen. Yeah, thank you, Priya. This is a really great characterization. The interesting thing with computer vision field is that over the last 10 years we have seen a lot of progress that's fast in the research field that graduates out of the research labs that people take into real applications, like what we're doing with the waste management here, who are really keen on innovation. And what's even more interesting is that the trend doesn't seem to slow down with the recent transformer and the head-to-head competition between convolutional architecture and the transformer-based architecture. The giants in the research labs are trying to make things better, and we are seeing the trend not slowing down, and people keep innovating here.
Yeah, thank you, Zizi.
I think, Brett.
Yes.
I'd like to make a comment real quick. I think when I look at this chart here, right, I frankly don't understand this at all. And one of the things that we really leaned on from a WM standpoint is the advice of Kung Fu. And they are so plugged in on kind of what's emerging and what's possible. We work with the Kung Fu team to talk through different use cases, and we converge on what's reality and what's deployable today. And then they give us a framework of, okay, well, this might not be necessarily here today, but we could probably solve this in the next year, depending on how fast and the technology adoption rate it is. So I think that's one thing that's very interesting, is maybe my takeaway, at least on this particular side, for the folks that are not so embedded in computer vision and understanding, is find a partner that you guys can go out and grow together and build that competency and leverage each other. I think that's really a key for us, is that it's not in our wheelhouse to do all of this. We really got to rely on experts like Priya and Zizi to help us come in and guide us and put the frame rails up and say, hey, this is what we can do. And this is the roadmap to accomplish it.
Yeah.
And Priya, I have a follow-up question on some of this, and it may be useful to stay on this slide, but let me know if not. So I am 6 years new to the artificial intelligence world and have a limited window of time where I've observed things change, right? And I feel like I've seen quite a bit of change in those 6 years. But now all of a sudden we go from computer vision and as we've known it, and now we're looking at things like vision transformers. Is it a reimagination of how we tackle computer vision tasks? Is this just a new tool in the tool belt of a computer vision engineer to tackle specific tasks? I'm just curious why. Why are we rethinking this? And are we just fighting for every inch and yard of additional accuracy gain, or are we truly solving something that was previously unsolved?
Yeah, this goes to the point of, the fact that compute and storage are now, possible at very huge scales, which makes it easy for us to mimic human kind of classification and human eye kind of recognition, right? So it's the convergence of compute, storage, and that enabling algorithmic progress. That's the real reason. So, and we are able to generate new data sets. We are able to keep up with new algorithms. Of course, the next frontier is reasoning, right? So recognition is done, right? So now we want to move into reasoning, right? To be able to do reasoning like humans, right? And across domains, right? So Microsoft has a VNO-VL model that's out there, which uses both vision and language models together. Which is kind of how we use all our senses, right, when we try to make a prediction. So I want to call on Michael Wharton, who might have a different perspective on this. I'm leveraging all the talent Kung Fu has, right? Somebody might have to unmute Michael.
Yeah, I think I'm unmuted here. Can you guys hear me okay?
Yes.
Yes.
Cool. Yeah, I think so. We're just in such an exciting time. There's so many new tools and strategies that come out, and we're starting to realize that baking in research and experimentation into these engagements is incredibly important, because I don't remember the last engagement we've done where we didn't use research that was less than 3 months old or something. I mean, it really is that new and that fast moving. So given that, I think there are also all these other sides that involve tooling and involve all this harnessing that you need to wire up. That's, most of what we do, it's 5 to 10% of it is the machine learning model, and there's all this extra stuff, pipelining, data cleaning, all that stuff's really important. So all that is to say, it's just really exciting time to be part of it. And I don't think I have anything technically to add on what Priya and Zizi have said here. But it's just a great field, and we're really excited to work with partners like WM that are patient with us and help us go on this journey together.
Out of curiosity, as y'all look through this and look this from a technical standpoint, is this making your jobs easier? Or is it giving more? Is this giving more kind of capabilities? What's the rationale behind kind of these models, or you call it?
Yeah, it's definitely getting better, right? So the accuracy is going up. We are doing things faster. The processing is faster. So yeah, it's exciting, as Michael said. But at the same time, this is not for, we're not doing fun for the sake of doing fun, right? This is actually it's a needle mover, right? So things that we couldn't have done in the past, we're able to do because of the advances, right? And that's the reason to bring in, to leverage the research. This research is January 10th, which is hot off the presses, right? And we are able to use. It's because other tool makers are also, ramping up, right? So there are other researchers who are making these, models available as well, right? In the different tools, in the tools ecosystem. So it's making our jobs easier as well and exciting. Yeah.
Yeah, thanks, Priya. And just a quick PSA, I saw a question come through the Q&A, which is amazing. We're actually going to answer a lot of questions, hopefully, that you'll have towards the back of this. So you're in the queue. And if you guys have questions along the way, please put it in the queue and we'll circle back to them. But Vu, so and I think you've alluded to this well, is to say, hey, this is all really interesting. At the end of the day, I have problems to solve, and I care less about how they're solved. I just hope that they get solved to the best of their ability. I want to get specific with you for a second and talk about, you've alluded to a couple of different projects in contamination and other key areas. We had the opportunity to work on a project together around rider safety, and I think it's a really interesting anecdote in application of computer vision. Can you talk a little bit about that project? And so you don't feel left out, I do have a visual aid for you too. So as you get into it, I'll pull that up, but you just let me know where you want me to steer it.
Yeah, I'll give you some context, and then I think you could dive in there and we can open it up. So this really derived from WM being a safety-centric organization, and I kept seeing all these emails sent out from a safety perspective that helpers in the back of trash truck drivers were getting hurt, and in some extreme cases they were being killed by distracted drivers. And I drive a fairly new car and whatnot, and I'm like, man, my passenger vehicle has the ability to alert me if I'm about to back up and hit something, or even those sensors that beep if you get close to something else. There's mechanisms out there. So we partnered with KUNGFU to say, hey, how do we start to develop something that we can put on the back of a trash truck to detect fast moving things that are about to hit it and alert the helpers back there via some type of signal, whether that's a Bluetooth signal to some type of vibratory mechanism, that they wear on their vest, or if it's a sound that comes off of the device itself, or maybe a blinking light. None of that, it doesn't matter what the mechanism, but it at least gives you some reaction time to just move out of the way or pay attention. Because a lot of times these folks are really focused on really one thing: grabbing the containers and dumping it and moving on to the next stop. They may look around their surroundings, et cetera, but they're really there to optimize and be efficient to continue on that route. And frankly, none of this existed. There was no device that was readily available, you can buy off the shelf, that you can just mount on a trash truck and move forward. So we, in partnership with KUNGFU, prototype something that showed the feasibility that, hey, this type of technology is feasible. And not only is it feasible, it's compact enough that it's a portable device, right? It doesn't need to be permanently mounted on a trash truck or anything like that. You can utilize it and move it around and whatnot. So I think when we start to look at it that way, we really saw the feasibility and the use case associated with putting something like this on our trash trucks. If you saved one, and I hate to equate this to kind of dollars and cents, and that's not the purpose of all of this, but hypothetically, if you saved or potentially saved somebody from getting hurt or even dying, I mean, from an economic standpoint, that's a lot of money saved. Just one life, right? From a moral standpoint, just one life is amazing. Like, that's a win in my book.
Yeah, Vu, and I have a video here to give people at least a little bit of a taste on how this model works. And I'm going to try to play it. I hope it comes across somewhat okay in the stream.
Yeah,
But
I'll walk through this.
Any color commentary on what people are seeing?
Yeah, so this is a mock-up of, and obviously we couldn't do this in real life from a simulation standpoint, actually hitting the back of a trash truck or anything like that. So the idea of this was set approximately to the height of where the trash truck would be and where the cameras will be mounted, et cetera. And we would do these tests to kind of, and here it is here, to show the object classification, the determination. And Priya, help me out here, and Zizi could chime in. We're actually, there's an algorithm associated with what we call a danger score. And if that danger score reaches a particular threshold, it will actually alert and trigger an alert and say. So right here, this is pretty unique situation where the car deviated from actually hitting the back of the trash truck and kind of past the trash truck, and it did not signal alert. So we were trying to work with different use cases and different scenarios associated with it. And then just here, that one just pulled up and slowed down in the back of the trash truck and therefore did not alert and trigger the event.
Yeah. So
Priya, any other commentary from your side?
Yeah. So just from the technical perspective, so we are doing detection, tracking, and risk score classification. So from a detection perspective, we used MobileNet SSD, single shot detector, which is better than the previous generation of Mascar CNN class of algorithms. And then for tracking, we relied on a heuristic, so intersection over union. And for the risk classification, we used random forest. And TF Lite was used for it, which makes total sense because this is on the edge. We need a lighter model. We need, less footprint, faster, low latency. So it makes sense to use TF Lite. And Zizi can talk about, the choices between the different edge accelerators we looked at. So we ended up going with Coral USB here. Zizi, if you want to talk through the choices and why.
Yeah, thank you, Vu, and thank you, Priya, for the great explanation here. Yeah, I can speak a little bit in terms of the choice for using edge TPU. We evaluate two choices. One is this kind of USB type of edge TPU, and the other is Jetson Nano from NVIDIA. Both are great choices. What I like about the edge TPU is that as a USB stick, you can easily develop on it on your laptop. And then once you finished training your model and exporting your model or burning it into the USB device, you can easily plug it into a edge device like Raspberry Pi. So that really makes the development process very easy. And I really want to thank Vu and WM team to work with us side by side from the conceptualization to data collection. Where Vu collected a lot of great data by simulating on the parking lot, as well as recording footage from the back of the truck, and then through model training and deployment. It's really a fun journey. Yeah, thank you.
One of the things I want to mention here, which is that last bullet, is that the device that we ended up creating, although a prototype in itself, but it was actually ultra low cost, right? This was put together in the matter of a couple $100 that we were able to do. Now, obviously, the software and whatnot was the kind of secret sauce to everything, but the hardware solution to this was elegant and extremely cost effective.
Yeah, and easy to deploy. Yeah, go ahead.
Vu, just to put a bow on this one, lessons learned, right? Because this is an interesting use case for a lot of reasons. And I think people are likely picking up on that. But in terms of deploying it and testing it and lessons learned, what were some takeaways for this particular project?
Yeah, Steve, great question there. Hindsight's 2020. I think when we were going into this, we were very bright-eyed and wide-eyed and saying, hey, we would, we think this is going to be great. If it saves a life, it is the end all be all. This is awesome. But as we continue to go through this, I think the accuracy for this particular use case was just not there, right? I mean, even if we got to a 99.9% accuracy rate, in just one particular instance, if somebody, didn't alert somebody and somebody did get hurt or died from that, that would be a fatal flaw, right? So I think in hindsight, looking back, we picked a use case that needed such a unattainable kind of accuracy rate and whatnot that, it wasn't deployable from a full scale perspective. From as we look to partner with KUNGFU, and we have on other use cases, we're looking at things that are more, call it tolerable to some errors, and not necessarily a life dependent on something like that, right? So I think that's really the takeaway is when you start to think about human lives and whatnot, you really need to be extremely confident that, and to the degree of 100%, which I don't think is possible in this, right? Because you can't plan every particular scenario. You can't simulate every scenario possible. You can only do as much as you can, and there's still gaps.
Yeah, there's a couple of key points there that I want to highlight here. One is that, and I see this a lot when picking practical applications or where to use machine learning, AI, even computer vision to solve problems, you have to think about the risks of getting the answer incorrect, right? And typically the higher the stakes will put you down a path of complexity that you have to be prepared for, and you have to have an answer for, well, what if we get it wrong? What's at stake here? In this case, it could be a human life. So sometimes the stakes are just too high relative to the value or even the capability of where machine learning is today, because there are plenty of 75% use cases where 75% of the time, computer vision works fantastically well and can drive a bunch of business value. On the flip side, in autonomous driving, 99.9999999% accuracy is still a fatal flaw in capability. So we have to weigh those things out before we take on any of these projects. On the other side too, it's a data problem, right? Part of the accuracy issue is a data issue because we were simulating all of our training data, and thankfully there was no ground truth for us to be able to leverage here. So how do we effectively train a model to keep someone safe if we can't show it examples of when it's been, when the incident is unsafe? So there were certainly some limitations to that as well. And these are all lessons learned that we can apply to future projects.
Yeah, it's a great segue to data simulation and data segment augmentation techniques. I noticed there were a couple of questions. Thanks, Travis and Steve. So yeah, I mean, when you don't have ground truth and when you have less than ideal feeds, right? So how do you work with the data that you have? So you rely on simulation techniques, right? So and data augmentation techniques. So there are plenty of tools out there. So my favorite happens to be Cornea, but there are plenty of other tools that are out there. ImageAug, has been very popular in Kaggle and continues to be used. And I know Michael Wharton can probably talk a lot about it. And I guess the second part to Travis's question on multispectral feeds, for that, I think I would pull in Steve Kramer, who's really the expert in multispectral feeds. Yeah. If not now, we can get to it during the Q&A.
Whoever's working the background of all this is amazing. People just pop up and unmute themselves. Kudos.
And very nice to get to meet you finally. So KUNGFU was lucky enough to get to work on the DARPA D3M, or Data-Driven Discovery of Models program, a large 5-year program that focused on automated machine learning systems. And our focus was on time series forecasting as well as remote sensing. focused on multispectral satellite imagery to do things like land type classification. There was also some applications related to food security, looking at trying to predict location of locusts in Africa before they went from the hopper to the flying stage. And so the good news is that lots of these techniques from computer vision can readily be applied not to just RGB or to standard video image, but also to multispectral data. In fact, and as folks on the KUNGFU side know, we're also seeing a lot of success even in other modalities like millimeter radar wave signals as well.
Thank you.
Yeah, excellent. Team, I want to pivot the conversation slightly and touch on a new topic, and we can open the floodgates to additional Q&A in just a few minutes. We have a labor shortage all across the board. Vu alluded to it. Machine learning, data science, AI engineers are not immune to this labor shortage. There is far more demand that outstrips the supply of really talented people that can solve some of these problems. So Priya, this is more of a question to you, because I imagine many people here are from the perspective of hiring machine learning engineers, partnering with them, or someone who wants to get into this space and is maybe technical by background, but not a computer vision expert yet, right? So from that perspective, and from your perspective, what do you see as the makeup of a successful computer vision practitioner? And if you're not there today, how can you get there? What resources are available to you to upskill your skill set?
Yeah, I mean, this is a great time to get into the field. And we are in a great time of democratization of all these techniques, right? So democratization of knowledge, right? So we have YouTube University, we have Twitter University, we have Coursera. We live in the age of papers with code. So, even before somebody, comes and works at a job, it's possible to, try and have a GitHub presence and, leverage all the code boot camps, even if you're not, trained in the field, right? So there's plenty of avenues. There are lots of course materials from Coursera to all the cloud providers. They've all committed, or each one of them has committed to upskilling software engineers into machine learning engineers and, AI engineers, because, just as Mark Andreessen liked to say, right, software eats the world. Now AI is eating the world, right? So every single product is trying to, in some shape or form, try to use AI. So there are plenty of resources. I mean, so I would say, leverage all the resources. Papers with code happens to be my favorite, but, I'm sure Michael Wharton has a different take on this. If you want to chime in, Michael. Yeah.
Sure. Thanks, Priya. Yeah, I agree with everything that you said. It's incredible to me that there's so many online resources out there now to just, even when I was in college, that did not exist. But I do a little bit of mentoring outside of working here. And a big theme that I always bring up is that if you start top down, like if you find something you're really passionate about and you actually build something, like you have that pragmatic edge, that's always a really good differentiator for applicants that we see. Even if you've trained a machine learning model in a sandbox and got it some validation and accuracy that you're really proud of, that's a really great accomplishment. But if you've done that and then written some unit tests, deployed it, built a server, and did all those extra practical things that are required to make it effective in production, that'll certainly make you stand out.
Well put.
Yeah, thanks, Michael. Vu, let me ask you a similar question from your perspective. If you were, waste management is WM. It'll take me a while to get used to that. WM is certainly scaling their own AI operations, building internal teams, partnering outside, looking all over the world for pockets of talent to help you guys accomplish the things that you want to accomplish. But from your perspective, as someone who's hired these people in the past, what type of skill sets do you look for? What do you like to see in someone that would give you confidence that they'd be able to help you solve problems?
I'm going to answer it by giving a little bit of a context to how I fit in the organization, and hopefully I actually answer your question. But we also we have a computer vision team, right? And they go out and they do what I call the core business. They actually go out and they don't identify use cases. They're already working on pre-identified use cases and honing in on it, et cetera. And that team is very much in its infancy, and they are extremely strapped for priorities and bandwidth, right? So what our team does is we need to go out and continue to uncover what else should we be doing in computer vision. And because we can't rely on that particular team because one, they don't have any bandwidth, we partner with folks like KUNGFU that help us get through, hey, does this work? And I think there's a gambit of ways we could go about doing this, but they can help us take it from A to Z, from start to finish, or they could help us take it from some partial implementation place and say, okay, yeah, this is feasible. Let's hand it off on all this information to the machine learning team. So when I look at competencies, it's really for the team that we're leaning on. Do they have the experience? Can they show us some use cases that they've done that are similar to something like this? And frankly, it's can they also learn with us in it, right? So a lot of the things that we're looking to do is relatively novel, not only in the waste space, but potentially even the computer vision space. And is that team particularly open-minded to going down and going on this iterative process of innovation? And I think that's what I really look for is the flexibility, the open-mindedness to go through this iterative process of innovation, and then ultimately the experience of what that team has.
Yeah, thanks, Vu. And that final question on this thread, because I'm super curious. You guys, Priya, Michael, gave the audience a really great sampling of successful resources and some knowledge that one would want to have to be successful as a computer vision practitioner. What about soft skills? Priya, from your standpoint, what type of soft skills are important for engineers to have to be successful, working in the AI space?
Yeah, so yeah, this is a great question. Definitely, it's a mix of art and science, right? Because you're going on the journey with the customer, with Vu, making the journey with them and, trying to figure out if the use case fits. Taking inspiration from, software engineering, you have, whether you have the data, whether you have, quality, right? Whether you have the resources and the time, right? So making that trade-off, even if you're using latest cutting edge algorithm, right? Are you able to leverage the data you have? Are you able to simulate the data you have, and making the case of describing, explaining why you need labels for something versus, why you might rely on something self-supervised, right? So doing that journey with the customer is quite key. So I think communication skills are likely, quite important here. But, different people come together, right? So, KUNGFU is especially good at this. I'm sure, Vu can talk to this, right? So how different functions come together, right, for the project. I think, yeah, being able to, it's a team sport at the end of the day. So I see that, Steven's, our CEO has joined. He might have input on this if somebody wants to unmute him. So, yeah. For a different perspective.
Priya, can you repeat the question for me?
So what kind of soft skills? We talked about all the core skills, a machine learning engineer might bring to a project, for a project like the one that we are doing for WM. But what kind of soft skills might you look for and hone in the journey?
Yeah, no, it's a great question, Priya. I'll start by saying that we really try to foster a culture at KUNGFU around things like vulnerability, to say, so that people feel comfortable saying, I don't know how to do something, or I think there might be a problem here that I need help with to try to address it. I may need another perspective, which is also leads into, we very much value diversity of backgrounds, experiences, perspectives, and all the various ways that diversity can present itself, so that we don't end up with, solutions that might miss certain angles to be able to be successful. And then, because most of the projects that we work on are really augmenting humans and people in their projects and work, we very much take it seriously and really put effort into trying to make sure that the ways that we work with our clients, and that the systems that we develop are intended to work with the people that they're built for, really take into account the people who are doing that work. And so, our team is incredibly thoughtful in all these areas and more. And I think those all go to the soft skills that really have nothing to do with, but are just, really just as important as all the incredible technical skills that Priya, Steve, Zizi, et cetera, all bring to the table. So I hope that was helpful, Priya. And thank you very much, Vu, for all your kind words about us too.
Oh yeah, no worries. I'll chime in here. I know you didn't ask me the question, Steve, but I'll answer it anyways. I think a soft skill that's extremely important for what a software engineer here is, frankly, the ability to tell folks in layman words what the hell is happening, right? Because I think sometimes you can get caught in the complexity of what's what, and when you do explain it, it's just goes in one ear and out the other. I think trying to find folks that are able to not make you feel stupid when they explain it to you, but also genuinely just dumb it down so that you can understand it and grasp the concepts, right? So it's not, and I'm not trying to pretend here, I have no idea in some regards of some of the things that Kung Fu does. And I have to ask questions, and they're patient, and they got answer in a manner that, hey, this is what's happening from a layman's perspective.
Yeah, thanks, Vu. Let's, in the remaining time that we have today, let's open up to Q&A. We've addressed a couple of questions in here, but I think the question from Travis around risk management, Priya, that might be a good one to talk to. So I'll read it to you. From a risk management perspective, isn't it better to have a partial solution, particularly if you understand the failure models versus no solution?
Yeah,
what are your thoughts on that conceptually?
Yeah, it's a judgment call, right? Depending on the use case. So, in the case that, we presented today with Vu, it's a life and death situation. So you make a judgment call, what is acceptable, right? It's a, hard question. So I think, there are ways to dial it down, dial the risk down. This is where the partnership between the business and the technologist works, better. I think, Max, I don't know if you want to chime in here from an ethics perspective, but yeah.
Yeah, hey. I can answer some questions about ethics, but I was sort of looking away at something else. What exact context will you?
From a risk management perspective, isn't it better to have a partial solution versus no solution? So I was saying, in the particular example that we were presenting, this was a case of life and death. And so you really have to work hand in hand with the business to figure out, what's the knob, where you want to land. But
yeah, I think that's a great point. And it is hard to know. One thing we talk about in ethics is when you make a prediction on something, you're sort of biasing the circumstances towards that prediction. Humans are sort of notably not very good at dealing with probabilities. This idea of like, oh, we have an 80% chance of success here. That really means 100% is sort of what you shift to thinking, because that's how our brains are good at processing this stuff, because 80% is pretty likely, but it's not 100%. And that's oftentimes missed with this prediction bias stuff. And so in these situations of life and death, it could be true that if the prediction says, yeah, you're pretty likely to be okay, but it's off in that 25%, or it's just wrong or something like that, you could interfere in a negative manner. Generally, the easiest way to combat this sort of stuff is just by educating people. If you just talk to the people who are using a system like this and say, hey, you have to understand that these are predictions and they're attempting to make the best choice. People sort of have an image of AI as being right all the time, which is not really correct. It's trying to make a prediction. And so being able to manage those sorts of like human biases in order to make sure that your prediction is being used to the correct extent is hard. And as for the sort of original question, is sort of this partial solution better than nothing if these things exist? And I think the answer is yes. It does manage to do a lot, and it does augment our own sort of ability to make decisions here, and it will help us make better decisions if you understand how or what the AI is doing and how to sort of deal with the predictions. So as long as you're educated and informed, I think it's definitely a positive. So
Thank you.
Thanks, Max. Vu, this one's for you. So after this effort, I have to imagine they likely mean the rider safety effort, but I think it generally applies to all of your efforts you've put forward so far to tackling AI problems. Are you generally feeling empowered? Or do you feel like your vision is different in regards to how you tackle future or other AI problems?
I think it's definitely empowered. I think as we start to look through technology, this is very much something that we want to fold into our organization. And I think we just, part of that is we just need to be extremely cognizant of the particular use cases that we tackle, right? From a risk management perspective, I'll kind of give my 2 cents on the WM as a culture here. We're extremely risk adverse in a sense that, and that's probably similar to a lot of companies out there you can probably name, right? When drivers or helpers continually hear potentially false positives, right, and they just get out of the way, sometimes you're just trained to say, okay, I'm not going to worry about that anymore. And that one time you don't do it, then you're really opened up to litigation, et cetera. That's really what it comes down to us when we started looking at this. Is, I mean, I'm at fault for this sometimes too. Back when I first started driving, I didn't necessarily wear a seatbelt all the time, and that buzzer would go off all the time, and I would just ignore it. And our drivers typically do that as well sometimes, right? They get in and out of the cab so often that there's all these sounds and things of that nature that occur. You just kind of put in the back of your mind, these are just noises, right? So we don't want to train folks to just always react and then they just get, complacent and figure out, okay, nothing ever happens, right? As an extreme situation. But I'm not discouraged by this at all. I think part of innovation is making sure that you fail, right? Or not making sure, but understanding and accepting that failure is okay. And you just get back up and just figure out how do you learn from those mistakes and continue to move forward. Right? You're not going to get it right every time. And that's part of what innovating is all about.
Yeah, thanks, Vu. In the interest of time, I'll take one more question. So I see one down here that seems to be pointed to me. So the question is, how would decision makers know if they're ready to apply AI, or how do businesses know, or really anyone who's interested in doing this but may not be able to do it themselves? There's a lot of answers to this question, and we could get quite technical, but how I usually coach people on this particular topic is start with your intuition on, is the culture ready for artificial intelligence? Think about the end outcome and the means likely you would follow to achieve that end outcome, and think through how your organization may respond to embracing it. Are users likely to trust it? Are they likely to distrust the technology? Are you generally, as an organization, as individuals, empowered or excited by the prospects of charting this new technology? Or are you generally afraid of it? What are the risks of getting it wrong? Are you risk tolerant, or are you risk averse? All of these things are cultural components. You have to think about the change management and how much changing of your own internal processes are required to embrace it. And if all of those things are check, culturally, I think you're really ready, and that's important. We've had plenty of successful solutions that were failures because people just didn't know how to use it. Even though it worked, they didn't really know how to use it and didn't want to use it. Sales predictions that were predicting 3 consecutive bad quarters. It's a bad way to set an impression when you're doing a sales forecasting model, right? People are like, no way, this thing's garbage. So you have to think about those types of things. The other one is organizationally, everyone's going to say data, and I'm not totally going to say data, but I'm going to kind of say data. You have to see data as an asset, as a corporate asset. You have to see that that information is something that is going to help you achieve corporate objectives and aspirations. And if you think data is the mechanism to help you, maintain your position or to compete or to better be a knowledge organization, and that is valuable to you, I think that's a massive box you have to check, because everyone has issues with getting data. Even the ones that have too much data have data problems. You're never going to get away from data problems, and these days models don't necessarily need a ton of data like you think they would. And that's going to increasingly become less of an issue, though it'll always be an issue. But if you see data as a corporate asset or a valued asset in the organization, and you think there's opportunities to derive value from it, that's the right mindset, because we can always get data. The first part is just kind of getting your mind right when it comes to tackling these problems. So hopefully more of a non-traditional way of answering that question, but hopefully a useful one nonetheless. So with that, I'm going to have to cap it. I'm so sorry. This has been such a fantastic and fascinating conversation. Huge shout out to Vu for joining us today and giving us the business perspective. Huge shout out to Priya for joining us and educating us around the technical specificities, and the corpus of cameos we had today, and how quickly they were able to add perspective, which was incredibly valuable. Thanks to everyone, and thanks for those who joined us. We are recording and we will distribute this. In case you would like to share it, we would love for you to do so. So hopefully you found this valuable, and have a great afternoon.
Take care, everybody. See y'all.
Thank you. Thanks, Vu.
Bye, everyone.